Hi everyone, welcome to this channel. My name is Lore and in this tutorial I will show you how to build custom chatbots that rely on your own private data, and for this we will use Langchain and Weaviate. So the idea is that we take a set of PDF files with information that we're interested in and implement it on top of OpenAI's GPT model, so that we have a chatbot that only uses our private data and does not rely on the information that GPT was trained on only. So without further ado, let's dive right into it. So as you all know, large language models have become increasingly popular, and especially OpenAI's GPT model has been used extensively recently in multiple different applications. However, there are some limitations when using OpenAI's GPT, especially because it has been trained on data available on the World Wide Web, and this data is only limited until September 2021, which means that if you want to use your own data or private data that's not available on the internet, that it's not capable of doing so. And with this disadvantage, there comes another problem, which is hallucinations. And this is when the model comes up with an answer that could be a good answer to your question, but actually it's something that is made up based on information that it has retrieved on the internet. So to overcome these two limitations, we will use Langchain's framework to combine our private data with OpenAI's large language model. And what is Langchain exactly? Well, Langchain is an open source framework that allows developers to easily integrate the large language models such as GPT or Hugging Faces and integrate it into their applications. There are many applications possible. We will use it for question and answering of a certain set of documents, but you can also do document summarization, analysis, and many more. So I really encourage you to look into the documentation of Langchain because it really has some amazing applications out there. But in this tutorial, we will focus on the question and answering, or the chatbot principle, of a set of private documents that we will gather. So the workflow that you can see here is exactly the workflow that we will implement into our own chatbot. So the first step of this framework is the extraction of data, or the extraction of text. And for this we will use a set of PDFs or Word documents, etc. Basically any file where you can find text in. We will extract the text, split it into smaller chunks, and embed it into vectors. What are vectors exactly? Well, vectors are numeric representations of your textual data, and these representations allow you to do different calculations on the vectors. So basically you can compare vectors and see how similar they are by doing some mathematical calculations such as the cosine similarity, Euclidean distance, and many more. So it's a way of being able to do large computations on your text data by transforming them into vectors. This vector embedding will also be done on the query or the question that you ask the model, and in this way you have a large data set of vectors of your knowledge database, and then you have the one vector of your query. And then, as I just mentioned before, you can check which of these vectors resemble most to the query vector you have. And in that way, you basically extract from your large vector database the vectors that are very similar to the query that you have asked. So I think that covers the theoretical part of this tutorial, and now we can go ahead with a deep dive into the code. So as you can see, we will use a Jupyter Notebook for this tutorial, and all the code will be implemented in Python. Before we get started, I want to give you an overview of the PDF files that will be integrated into our chatbot. So these PDF files contain all the information that will be integrated in our chatbot, meaning that our chatbot will have access to this information and we can ask questions about the documents. So I will be using two PDF files which I have extracted from Wikipedia. The first one is from the GPT-3 Wikipedia page. So here we can find all the information on the GPT-3 model. And then secondly, I have downloaded a PDF file from the Wikipedia page of OpenAI, which contains all the information about OpenAI. To run this code, you will need to install some dependencies. First of all, we have the Langchain package, which you can install using pip. Then we have the Weaviate client to interact with our vector database. And finally, we have the OpenAI library to interact with our large language model. So let's go ahead now and run our code. As you can see here, the first thing that I do is loading in some variables, because to run the OpenAI algorithms, you will need an OpenAI API key to access the models, because you have to pay for them, and the OpenAI key is linked to your account. I have stored them into an .environment file so that my keys remain private during this tutorial. The same is true for Weaviate. You also need an API key to interact with your account and the name of your Weaviate cluster. So now let's go ahead and read in our data. So in the first step, you can see that I use this directory loader that is contained in the Langchain package to load in the PDF files that are contained in this folder, which you can see here. Those are the PDF files that I just showed you. If we run this code, the PDF files will be loaded in a data object. And we can also check how many documents will be loaded into the data document. And we can also count the number of characters that are comprised in our document. So this will take a couple of seconds. There might also appear some warnings, but usually they don't cause any issues for further running the code. So you can simply ignore them. So once our file have been loaded, you can see the number of documents that were in the data and the number of characters in the complete document. So here you can see that our two PDF files in total contain 90,173 characters. If you want, you can also take a look at the data object itself by running data, and here you can indeed see the text that is comprised into the PDF files. So now we can go ahead and start splitting our text. We want to do that because each chunk of text will be comprised in a vector, and we don't want them to be too big, because otherwise they would be too large pieces of text to put in our GPT model, and actually the GPT model has a limited input size. So once you enter a large number of inputs or tokens into the GPT model, it will crash. So you can't make your chunks too big, otherwise they won't be suitable as an input for GPT. So from the Langchain library, we use this recursive character text splitter module, which allows us to cut our data into smaller chunks. And here I define a size of 1000. You can play around with this chunk size. However, as I just explained, the larger you make it, the more you run at risk of having too big of an input into the GPT model. You also can decide to have some overlap between the different chunks. I set this parameter on 0 here, but feel free to play around with these parameters. So when we run this code, you will see that we have different documents, and you can take a quick look into these documents by running docs, and indeed you can see that this comprises of smaller chunks of text. So this is a chunk of text, this is a chunk of text, and if you count the number of characters in each chunk, it would be 1000. Also, you get a property metadata here, which gives you the source of the text, which is here the OpenAI PDF file. And actually, you could use this metadata to also give it as an output of your chatbot, so that people know where exactly the answer came from. So it's a very nice feature, and something that I could demonstrate in another video if you would be interested in this. So once we have split our text into smaller chunks, we will embed the chunks into vectors. And this we will do using OpenAI embeddings, which is also integrated in the Langchain library. So by running this code, we create the embeddings. Once we have all the vectors from each chunk of text, we will then need to store the vectors into a vector database. And as discussed before, we will use the Weaviate vector database to do so. Also in Langchain, you have a module embedded, which is the Weaviate module, which you can load using this piece of code. In this piece of code, we will connect to our Weaviate cluster using our Weaviate key and our Weaviate cluster URL. To obtain this key and URL, you can create a profile on the Weaviate console and create a free sandbox cluster yourself. It's a very easy and straightforward process, and once you've set up your free cluster, you can run it free for 14 days. On this website, you can also obtain the cluster URL and the API keys, which you then need to connect via the Langchain module. So when we run this code, we are connected to the cluster. In the next step, we need to define the structure of our vector database, and you will see a lot of different parameters here, but the main important ones is the name of the class we will use to define our vector database. Also, the name content is important, and what you can see here is that we will use the OpenAI 8AA model to do the vector similarity comparisons between our vector database and our query vector. So when we run this code, we actually just create the vector store. There are a lot of parameters that you can play around with. If you're interested in that, I would highly recommend you to jump into the Weaviate documentation, which is very interesting, and there are a lot of things you can do with their vector databases. So once we have our vector store, we can start to load in our pieces of text, which we do via this command. So the docs variable contained all our chunks of text. So for each chunk of text, we will extract the page content, but also the metadata, and add it to the vector store, as you can see here. So let me run this piece of code. And voila, that's it. We have now our vector store with all our data in there, which we can use to query with our chatbot actually. When we actually ask a question to our chatbot, there are two steps that are completed. And the first step is performing a similarity search, which means that the query is converted into a vector on its own. And this vector is then compared to all the vectors that we have stored into our vector store to extract the best or the most similar vectors. And we can do this using the similarity search module, which is also included in the Langchain package. We give it the parameter or query, which is here the question, who is the founder of OpenAI? And then also the number of pieces of text that you want the similarity search to extract from your vector store. So when we run this query, we will get normally 4 pieces of text that are highly similar to our question, who is the founder of OpenAI, and also very likely contain the answer to our query. So here you can see the 4 chunks that are most similar to our query, and these 4 chunks of text we will pass it to the OpenAI GPT model, which will then formulate a nice and naturally sounding answer for it. To do so, we use the load Q&A chain from Langchain, which is an easy function to combine the large language model and the query that you want to use. So as you can see here, we again need our OpenAI key. We also have some parameters that we can play around with, but these are just the default parameters that I've been using here. Again, you can find more information in the documentation of Langchain. And then the last line is running this chain. As input, we have the 4 chunks of text that are highly similar to our query, so these ones, and then also the query itself. So let's run this command, and then we get the answer, Sam Altman, who is the founder of OpenAI. To show you that our chatbot only replies on questions that are integrated into the vector database that we supplied it with. So in our case, we gave it 2 PDF files regarding GPT and OpenAI, so you don't expect it to answer to any other questions that are not related to this documentation. So to show this, I can ask the question, what is the age of Madonna, which is not information that should be in the Wikipedia page of GPT and OpenAI. So first we do a query, and then we do our load Q&A chain, and we get the answer, I don't know, which is what you would expect. If you would ask this question on ChatGPT, on the other hand, you would receive an actual answer on this question. So by running this Langchain library with our custom vector database stored in Weaviate, we can get results that are restricted to the documentation that we provided with. So this is already the end of the tutorial. If you liked the video, please give a thumbs up or let me know in the comments below if you would like to see more of this kind of videos. If you're interested in building your own custom chatbot, but you don't know where to start, please check out my website, parrot.eu, where you can also reach out to me or follow me on Instagram. Thank you very much, and hope to see you next time. Bye.